extended version of the midterm presentation, but I'll cap from the top. This is our project group. Hamdi and me, we are from the University of Amsterdam. Ilka is from Helsinki Technological University. Marcos is from CVC Barcelona, and Petr is from Czech Technical University. The goal of the project is to create a responsive photo frame, which basically records what the user is doing and then selects an appropriate response to the user. We have defined some modules of the project, but this changed in time a little bit. The first module is an offline segmentation module, where let's assume that we are creating an interactive photo frame of a baby. This is what we did. We start with an external set of videos, which are automatically segmented by an analysis module. And then a segment library is created. This segment library contains small pieces of video that the system will play during its usage. The second module is a real-time feature analysis module. Presently it only works on visual features, but we were thinking maybe we could also integrate some audio features and integrate it with the Semaine API to make this multimodal. What it does is, during the operation of the system, it basically records the signal, does an analysis based on effect, and maybe on other things as well, and then feeds these features to a program logic, which is the third module of the system. The program logic receives the features from an external module and then selects one segment according to the activity levels in the features. This module also includes learning, so it's supposed to work on the feature segment combination in its offline mode to improve the interaction between the user and the system. Then there is a fourth module, which is the interface. Basically, what are we going to show the user and how we are going to give feedback, because we're not interrupting our segments to give immediate feedback like Dennis's group is doing. So we have to find a faster way of giving feedback to the user to improve the interaction. And finally, we also postulate there is a dual frame mode of the system on which we have not worked yet. But what we can do is, during the operation of the photo frame, since we're already getting visual input to synthesize the video, we can store these visual input, do an offline segmentation, and send it over to a different frame in a different place. So if I'm, for instance, viewing the photo of my child on my laptop, let's say, the system can at the same time record my segments and create a photo frame of me to be displayed for my child. And that makes sort of sense, because when the child is interacting with my frame, then there is some sort of ground truth, because I know for which video the child gave what response. So I'm storing this along with the segments. And when I'm playing the new segments, then I can use this ground truth. So we did a number of video recordings to start with, 1.5 and 2 minutes from the same individual. We manually annotated it with the Envil tool, but then we also created the automatic segmentation module, which is based on feature tracking over the sequence and a corner detection, and then basically an optical flow algorithm. So what we're doing is we're analyzing the movements, the optical flow in the video, and this gives us sort of the level of activity in the video. Now, this could have been extended to perhaps also effect analysis of the video, but with the baby, for instance, it's very difficult, because the baby's face does not conform to the facial morphology of a normal human face. And the facial action units, for instance, are different for babies than for normal people. So basically, if you want to read the emotions of a baby from the face, you need to train the system with babies' emotion videos, which is a lengthy and complicated process. So we threshold the optical flow energy and find calm and active segments for the baby. And then we link this to the emotional response of the user of the system, which we are in better situation to analyze. The optical flow for a given video looks like this. So we smooth this and basically we look for valleys before peaks. And the red lines are the results of the automatic segmentation, and the boxes up there are the results of manual segmentations from 5 users, basically 5 group members. So you'll see that the boundaries that we have selected are not very different than the boundaries that are automatically selected. So here is a calm segment of the baby, where the optical flow energy is not much. So this can be a response to a calm expression, let's say. And here is a more active example where you can activate this by, for instance, an angry face or a surprised face. The real-time feature analysis can potentially work with many features. So we have the Viola-Jones face detector, which activates the system. So when the baby is in a very calm segment, let's say in a sleep mode, when the photo frame detects a face, it goes into active mode. Then, during the operation, we can do a face detection. We have an eye detection where it determines where you're looking at. We have the optical flow energy to measure the activity levels. We can use some color features to introduce novel objects into the view and use those objects to activate some segments. And then we also have an emotion system basically for identifying 6 basic expressions. We didn't have time to implement all these things. Some of the features are easy to implement but more difficult to connect to the system, so they should involve some sort of learning. We focused on the emotion system. This is the example that I've shown on the midterm presentation as well. This is how the eye detection and face detection work. The emotion system that we use basically fits a face mesh, a Bezier volumetric curve to the face image, also following a face detection by Viola-Jones. And then it used a tracker to track these deformations in this base mesh. And we have 12 motion units, so we're basically looking at certain points on this mesh and in which way they're moving with respect to the face frame. And from those movements, we have a naive Bayes classifier to go to the expressions. And these are the 6 basic expressions: happiness, surprise, anger, disgust, fear, and sadness. And some of these expressions are very difficult to actually mimic or synthesize. So although you can recognize these expressions in people, happiness and surprise are very prominent expressions, but disgust, fear, these are more subtle expressions. So it's very difficult, for instance, to discern disgust and sadness. But this is how the system works in real time. So what it does is it returns a 7-dimensional vector, normalized, giving the probability of a certain expression at each point. So here Roberto is showing surprise, sadness, a little bit of anger, now more surprise, and he's smiling, so he's happy, he's maxed out. So the idea is to use this system to drive the expressions to the segments of the baby. The system response is a fine